Welcome viewers, in this video we will see the details about digital counters. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic digital counters. First we will see what is the counter. A counter is a register capable of counting the number of clock pulses arriving at its clock input. Count represents the number of clock pulses arrived on arrival of each clock pulse. So this counter is nothing but the name itself. It is a counting. It is used for counting the numbers. It is a sequential circuit. So every clock pulse, the execution is happened with every clock pulse, right? So it will count the clock pulses. So it is nothing but a register. Register means it is made up of flip-flop. We know that flip-flop is a storage element. It can store 1 bit data, right? So counter is nothing but a register that is made up of flip-flop. It is also a sequential circuit. So every clock pulse it will count the inputs, right? In that two types available, up counter and down counter. In case of up counter, the count is incremented by 1. In case of down counter, it is decremented by 1. Both are available, up counter and down counter, starting from 0, 1, 2, or it is from maximum number to minimum number. It's called a down counter, right? Now we'll see the logic diagram of this counter. The diagram shows the logic symbol of a binary counter. This is the n bit counter. As clock pulse is given, this is the output. N bit output is available. So this is the normal clock pulse, positive edge triggered clock pulse. This is negative edge triggered clock pulse, inverted. So every positive edge, this clock pulse is, this counter is executing the output. Here every negative, so it is a negative edge, it will execute the output, right? What is a positive edge and a negative edge triggered? So this is nothing but clock pulse is available. So this is 0, this is 1. So this is the rising edge. This is called positive trigger. Changing from 0 to 1 is a positive trigger. Whenever the clock pulse 0 to 1, it will start execute. This negative edged means whenever changing from 1 to 0, that is going down. This is called a negative edge triggered clock pulse. This is positive edge triggered clock pulse. Whenever the clock pulse changes from 1 to 0, it will start counting, right? So sequential circuit, arriving every clock pulse, the output is executed. So in this, the clock pulse changes from 0 to 1, it will execute. Here 1 to 0, this clock pulse will execute, inverted. It's called a positive edge. This one called a negative edge, right? N bit counters, so it will produce the n bit of output. Now we'll see the further description. External clock pulse is applied to the clock input of the counter. The counter can be positive edge triggered or negative edge triggered. That is what we discussed, right? 0 to 1 is positive edge triggered. 1 to 0 is the negative edge triggered. The n bit binary counter had n number of flip-flops, so that it will produce 2 to the power n of 2 to the power n states of output, right? So n flip-flop, n bit counter means we need n flip-flops, so that the output number of output will be 2 to the power n states will be available. Now we'll see the example. For example, if it is 2 to the 2 bit counter, if it is 2 bit counter means 2 flip-flops are needed. So 2 to the power 2, 4 states will be there, right? 2 bit counter having 2 flip-flop, 2 to the power 2, 4 possible outputs are available. 0, 0, 0, 1, 1, 0, 1, 1. Similarly, 3 bit counter having 3 flip-flop, 2 to the power 3, 8 states will be there. What are the 8 states? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. We know that all here first digit is 0. Then we have 0, 0, 0, 1, 1, 0, 1, 1. For next 4 combination, first digit is 1. Again same thing repeat, 0, 0, 0, 1, 1, 0, 1, 1. So totally we have 8 states are available. So the maximum count that can binary counter is 2 to the power n minus 1. That is 2-bit binary counter. The maximum count is 2 to the power 2 minus 1. That is equal to 3. right? So there are 3 counting will occur, right? So for a 2-bit we have 3 countings are occur. After reaching the maximum count, the counter resets to 0, right? After reaching, again it will goes to the reset to 0. Again it will start from 0 on arrival of the next clock pulse, and it start counting again. So 2-bit counter means it's 0. First digit is 0. Thereafter we have 0, 1, 1, 0, 1, 1. 3 states. 0 is excluding 0. There are 3 states. So totally 4 states are there, right? After reaching the 4th state, again it will goes to 0. Again it will start from 0, 0, 1, 1, 0, 1, 1, right? So the 2 digit mean 4 possibilities. After reaching the 4th possible, again it will reset. Now we'll see the types of counter. There are 2 types of counters available. So asynchronous counter and synchronous counter. Asynchronous counter, or it is also called a ripple counter. What is asynchronous counter? The name itself asynchronous. A binary or ripple or asynchronous counter consists of series connection of complementing flip-flop. Complementing flip-flop means each flip-flop got the complemented clock pulse. With the output of each flip-flop is connected to the clock input of the next higher order flip-flop. The flip-flop holding the least significant bit receive the incoming clock pulse. Suppose there are n number of flip-flops available means only the least significant bit, that is the first flip-flop, will receive the clock pulse. Second flip-flop receive the clock pulse is nothing but output of the first flip-flop. Similarly, the output of second flip-flop is given to clock pulse of the third flip-flop, right? So the clock pulse given to only first flip-flop. The first flip-flop output is given to clock pulse of the second is given to the third. So that it is called a asynchronous, right? The clock pulse given to only first flip-flop. After executing the first flip-flop output, then only the second flip-flop will start execute. So the operation is not synchronized, it is asynchronized, right? Output of first flip-flop will decide the output input of the second flip-flop. That's why it is called a asynchronous, right? So this similarly we have synchronous counter. Synchronous counter means when counter is clocked such that each flip-flop in the counter is triggered at the same time. Here n number of flip-flops are there mean only the first flip-flop receive the clock pulse, second flip-flop receive the clock pulse from output of the first flip-flop. Like that it will goes, right? So that is asynchronous. But here all the flip-flops are triggered at the same time. Clock pulse given to all n number of flip-flop. Then this counter is called a synchronous counter. The name itself synchronous. All the flip-flop output is synchronized by applying the clock pulse to all the flip-flop. Now will this compare this? What is the comparison? What are the similarities? What are the difference available between synchronous and asynchronous counter? So this comparison available is a serial number. First one is asynchronous or ripple counter. Second column is synchronous counter. All the flip-flops are not clocked simultaneously. Only the first flip-flop is clock pulse given. Thereby second flip-flop got the clock pulse from output of the first flip-flop. It is not simultaneously, but all the flip-flops are clocked simultaneously. Same time clock pulse is given to all the flip-flop. The delay time of all the flip-flops are added. Therefore, there is a considerable propagation delay because the second flip-flop depends upon the output from the first flip-flop. Third flip-flop depends upon the output from second flip-flop. So there is a propagation delay is there. All are added together. But here there is minimum propagation delay because all the flip-flop receive the clock pulse, so that it will execute the output simultaneously. So considerably the propagation delay is reduced. Right. Based on that, the speed of operation is low because propagation delay is more. Automatically the speed of operation is low. Here the speed of operation is higher, simultaneously triggered. Logic circuit is very simple, even for more number of states. Digital involves complex logic circuit. The number of state increases, but here it is very simple, right? because we are not triggering simultaneously. We are depends upon the one by one flip-flops are triggered, but here all the flips are triggered, so we need to check the what is the logic circuit. Minimum number of logical devices are needed. The number of logical devices is more than the ripple counter. Here more number of logical devices are needed, right? Finally cheaper than the synchronous counter, costlier than the ripple counter. This will be simpler, right? So the only disadvantage in the asynchronous counter is the propagation delay is there, speed of operation is low, but the design is very easy. No need to worry about the logic circuit, right? One by one flip-flops are connected. Output of one flip-flop is connected to clock pulse of the next flip-flop. So the logic device is very low, but the speed is so lesser, but the design is very simple. Here all are clock pulse is given simultaneously, so the propagation delay is lesser, but we need to check the logic circuit. For every clock pulse we need to check the logic circuit, so the design is complicated, simultaneously the costlier, it become more costlier. So in this video we discuss about the digital counters. What is mean by digital counter, what are the types available, synchronous and asynchronous, and also we compare the synchronous and asynchronous counter, what are the similarities and differences available. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.